Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So calculate the ratio of the resistances of the aluminum wire to the copper wire. So we have the length of the copper wire. This will equal 24 meters. We have the length of the aluminum wire. This will equal 10 meters. We have the diameter of the copper wire. This will equal 1.8 millimeters. Diameter of the aluminum wire, 2.2 millimeters. So we can say that the radius of the copper wire is going to be 0.0009 meters. Radius of the aluminum wire is going to be equal to 0.0011 meter. The resistivity of the copper wire is equaling 1.68 times 10 to the negative 8th ohms meters. And then the resistivity of the aluminum equals 2.65 times 10 to the negative 8th ohms meters. So at this point, we can say that the radius of the resistance of the aluminum divided by the resistance of the copper is going to be equal to the resistivity of the aluminum times the length of the aluminum divided by pi r of aluminum squared. This will be divided by the resistivity of the copper times the length of the copper divided by pi, the radius of the copper squared. So this will equal the resistivity of the aluminum times the length of the aluminum times the radius of the copper squared divided by the resistivity of the copper times the length of the copper times the radius of the aluminum squared. And we can solve and say that this is going to be equal to 2.65 times 10 to the negative 8th times 10 times 0.0009 squared. This will be divided by 1.68 times 10 to the negative 8th times 24 times 0.0011 squared. And we find that the resistance of the aluminum divided by the resistance of the copper is going to be equal to 0.44. So this will be our ratios of the resistances of the aluminum wire to the copper wire. That is the end of the solution. Thank you for watching.